Welcome back to the channel. Today I'm come up with a new topic in introduction to civil engineering. Before entering into the topic, I'm Vignesh Darshan, Department of Basic Science, currently in second sem, CSEA program from Devo section. So the course code of introduction to civil engineering is BES CK204A. Today we are going to solve a problem on determining the centroid of a given lamina. Before that, what is centroid? Let's understand it. So, centroid is a point where the whole area of a lamina is concentrated. When a plane figure is given, the centroid point holds the whole area of the lamina. That is centroid point. Calculating of centroid point means determining x distance and y distance as shown below. If we take this as a figure, then G is the centroid point which is to be determined. To determine this centroid point, we need to find out y x distance and y distance using formulas of given shapes. Let us see centroid of some known important geometrical figures. First, let us take a rectangle. To determine the centroid of any shapes, we have to calculate area first. So the area of rectangle is breadth B into depth D, and x distance of rectangle is half of the breadth and y distance of a rectangle is half of the depth. Similarly, for triangle, the area is half of the breadth into depth, and x distance is half of the breadth and y distance is 1/3 of the depth. This is depth of the triangle and this is breadth of the triangle. Similarly, for right angle triangle, the area is same as triangle, half of the breadth into depth, and x distance is 1/3 of the breadth and y distance is 1/3 of the depth. For circle, the area is pi r square, as we all know that r is the radius of a circle. So the x distance is r and y distance is also r for circle. And for semicircle, there are 4 different cases for semicircles. One is above x-axis and one is below x-axis. One is towards the right side of the x-axis, y-axis, and one is towards left side of the y-axis. So the area is similar for in all the cases of semicircle. It is half of the area of circle, pi r square by 2. For semicircle above x-axis, x distance is half of the depth and y distance is 4 times of its radius divided by 3 times of pi. And when it is below the y-axis, then d half of the depth, that is d by 2, is x distance, and minus 4 times r divided by 3 times of pi is y distance. When the semicircle is towards the right side of the y-axis, the x distance is 4 times of its radius divided by 3 times of pi, and y distance is minus d by 2, that is minus half of the depth. Here d does not represent depth, it actually represents diameter. Here, when the semicircle is towards left side of the y-axis, then the x distance is minus 4 times of r divided by 3 times of pi, and y distance is half of the diameter. It's not depth, it is diameter. And then for quartered circle, the area is 1/4 time of area of circle. Area of circle is pi r square, as we all know. When we divide it by 4, it's area of quadrate circle. So let me erase this. And x distance is 4 times of r divided by 3 times of pi, and y distance is also same as x distance. So without any delay, let's solve a simple example problem. So here example problem is, determine the position of the centroid of a lamina with a circular cutout shown in figure. So this is a figure. First we have to check whether the figure is symmetric or not. If it is symmetric, then either y distance or x distance becomes 0. But in this case, it's not symmetric. So we have to divide the given lamina into known shapes like rectangle, triangle, circle, semicircles. So here this lamina is divided as triangle, semicircle, rectangle and circle. And then we have to name all the shapes with number 1. This rectangle is named as 1, and semicircle is named as 2, triangle is named as 3, circle is named as 4. So to solve it very easier, we can make a table in which first it contains components, that is shapes, then area of those shapes, x distance, y distance, then when we multiply area into x distance, area into y distance, we get ax, ay. We have to make a table in such a way. Later we have to calculate the area of each components. First, the area of a rectangle, we are going to calculate it. The area is, as we all know, it's breadth into depth. So here the breadth is 120 and the depth is 100. Here it is given the radius of the semicircle. So 2 times of radius makes a side of rectangle, which is equal to 100. So 120 into 100. We can use a calculator. 120 into 100 is equal to 12,000. Similarly for triangle, it's half of breadth into depth. 120 is the breadth, 60 is the depth. This is 60 is the depth, and half of it is equal to 3600 millimeters. Here every units are in millimeters, so let us take it as millimeters. Next, for semicircle, it's pi r square by 2. Here r radius is 50. So the answer is, after calculating, we get it as 3926.991. And for circle, the area is pi r square. For the smaller circle, the radius is 20. So 20 square into pi. After calculating, we get it as 1256.637. Let us take it this value in negative, because we need to subtract this circle from this rectangle. First, let me clear all this. Next, we have to calculate x distance of all the components. For rectangle, the x distance is, we can use this table for solving. For x distance of rectangle is b by 2, that is breadth, half of the breadth. Here the breadth is 120 divided by 2, which is equal to 60. For triangle it is 1/3 of the breadth, which is equal to 40. And for semicircle, x distance is 4 times of radius divided by 3 pi. We are adding 120 is because diameter is 20 millimeter from y-axis. To calculate the x distance, we need to add this x value with the shape from y distance. Similarly, for triangle, it's 1/3 of the breadth, which is equal to 40. We have completed this. For circle, r is the x distance. Similarly, y distance using formula, it is depth by 2, which is equal to 50. Here 100 plus 1/3 of the depth, which is equal to 120. Even here we are adding 100 because the triangle is 100 millimeter away from the y-axis. Similarly, for semicircle, it's half of the semicircle, it's half of its diameter, which is equal to 50. For circle, it is same, half of its diameter, which is equal to 50. Then later, after adding area into x, we get these ax values. This for triangle, for semicircle, and for circle. Adding area into y, multiplying area into y, we get ay. For rectangle, triangle, semicircle, and circle. Later, finding the sum of all the areas of all components, we get the total area has this value 18270.354. For ax, the sum of all ax of all components is this after calculating, and for ay we get this value. Later, to find the x distance, this x bar, we need to divide ax by area to get the x distance, and to get the y distance we need to divide ay by the area, we get the x distance. In this way we can solve the problems of every given lamina.